Okay, everybody, so in this video I want to do just one more related rates problem, okay? And as I read this, I hope that even if you haven't seen a problem exactly like this, that it does sound like it's a related rates problem. So let's read the presentation of the question and then think about why it's a related rates problem, and then we'll work out a solution from there, okay? So the question's posed something like this. Say we've got this curve, and for this example, it'll be y is equal to root x, okay? And here's the xy plane, and information is given like this. There's a point that's moving along this curve, okay? So you can imagine that happening. Just like my pencil here is tracing a path right along that curve, and it's moving at a certain speed, I guess you could say. The information on this question is given that we're moving on that curve in a way that the y-coordinate of the point is increasing at 3 units per second. So no matter where the point is on the curve, its y-coordinate, meaning, this direction, is increasing at 3 units per second. So you got to think, if you're moving on this curve, you're moving right and up, okay? There's two components of your motion. There's a rightward motion and an upward motion. And, one or the other could be moving at a different speed. Okay? So you might even imagine, like, if I was moving on this curve, suppose that the point could cast a shadow on the y-axis, and that'll be where my finger is. Then as the point moves on the curve, my fingertip moving upwards as I match over to the point would be the y-coordinate. That's how the y-coordinate's increasing. So you got to think that for every second that goes by, just the y-coordinate is getting 3 units per 3 units bigger, okay? Anyway, okay, question is, at what rate is the x-coordinate changing when x is a third versus, say, when x is 4? Okay, so I hope that sounds like a related rates question, because the speed at which the y component is increasing, given that you're on this fixed path, completely determines the speed that the x coordinate is increasing, okay? Now, which one of these do you think would give a bigger answer? So we'll definitely talk about the math, but when I can, I like to bring instinct into this. Like that even if you didn't know the answer, could you some way reason yourself to believe that one answer would be bigger than the other or something like that? So I want to do some thinking like that because I think it's good for me to encourage you to think like that. So here's a curve right here, and it's not exactly like the curve that we're looking at on the other page, but each one of these jumps here, like say from here over to here, or from here over to, say, this point right there, is 1 second of time, okay? And I got this ruler and I made a scale, and that's 3 units up. Now, imagine if you were on this part of the curve, where the curve is more vertical, say, than it is over here. Then to move 3 units up would require you to move 2 units to the right, okay? So because of the shape of the curve right there, you don't have to move quite as far to the right in 1 second as you do up. But what about over here where the curve is flatter, where the curve is more horizontal? Moving 3 units upwards requires you to move 10 units to the right. So in 1 second of time, you're moving more than 3 times further to the right than you are up when the curve is more horizontal. So here's what I'm thinking. Here's how that translates to this question. Your y-coordinate is changing by a constant 3 units per second. And when x is a third, which is, on this end of the curve, versus when x is 4, which is more over there, the x-coordinate will not be moving as fast here, but will be moving considerably faster there, just like in that other diagram I showed you. So I think the answer to part B will be significantly bigger than the answer to part A. Let's see. So let's actually solve it. Okay, so here's the information we have. dy over dt, that's the change in the y-coordinate with respect to time. That was given to be 3 units per second. We know that x and y are functions of t because if you're moving along the curve and if the y-coordinate's increasing by 3 units per second, then the x-coordinate has to be changing too. So x and y are functions of t, and we want to find dx dt, the rate that the x-coordinate is changing. Okay, so we take the operative equation that links the variables together, which is that they're on that curve, y is equal to root x, and we take the derivative with respect to time, given that x and y are both functions of time. And that will give us this derivative of y to the first power is 1 times dy dt, which that's the chain rule right there. Derivative of root x is 1 over 2 root x times dx dt. That also is the chain rule. You can solve for dx dt pretty easily here. You know dy dt is 3. And say you multiply by 2 root x to solve for dx dt, you'll get 6 root x, okay? All right, so there's our formula for the rate that the x-coordinate's changing. So let's do this. We'll say dx dt under the condition that x is equal to 1/3 will be 6 times root 1/3, or we could say 6 over root 3. Okay, and I'll say units per second, right? Units meaning every mark on the graph. Okay, maybe you could rationalize this. I don't see a whole lot of a point to doing that, but you could say this was 6 root 3 over 3, or also 2 root 3 units per second. Okay, so either one of those will work. It doesn't matter. And if the question happens, say, to round to so many decimal places, we could do that on top of everything else. What about this one? What is dx dt when x is 4? Well, all right. This is our formula for finding dx dt under whatever condition you want. If x is 4, I'm going to get 6 times root 4, which is 12 units of distance per second. Which is faster. That's faster. That is definitely faster than that. This is about 3.4 units per second, and that's 12 units per second, okay? So that's a lot faster. Well, that matches up with our intuition, doesn't it? If you just think about it, when the curve is like this, y is changing faster than x as you move along the curve. When the curve is like this, x is changing faster than y. And that's all we're getting is confirmation by way of numbers when we solve it and answer this question.